Modern web applications depend on asynchronous client-server communication. This is the process that allows a browser to update specific parts of a page with new data without requiring a full reload of the entire document. To maintain this dynamic state, the system relies on a constant transfer of data packets, moving between the user's browser and a remote server. Historically, transferring complex data structures across a network was a significant engineering challenge. Early methods often involved heavy overhead and translation protocols that added latency to the parsing process. Efficient web architecture requires a standardized data interchange format, a text-based structure that is lightweight and can be easily generated or parsed by different programming environments. Json, or JavaScript Object Notation, was introduced to address this need, eventually being codified under RFC 7159. It is identified in network headers by the MIME type application/JSON and is stored using the .json file extension. Rather than being a complex markup language, JSON is a specific subset of JavaScript syntax. It reduces data down to two primary structures: collections of name-value pairs and ordered lists of values. Because most modern programming languages, from Python and Java on the server to JavaScript in the browser, include libraries to handle these structures, JSON allows disparate systems to exchange data using a shared format. We can see this exchange in action by intercepting a raw JSON payload as it travels over the network during a standard web request. This code snippet represents the raw intercepted data. While it contains a nested hierarchy of information, it is built using only a few basic syntax rules. The first structure is the object. The entire payload is contained within these opening and closing curly braces. In JSON, an object is an unordered set of name-value pairs. The name is always a string in double quotes, separated from its value by a colon. Here, the value for the title key is a simple text string, also enclosed in double quotes. However, values can also be nested objects. By nesting these pairs, JSON can represent complex, multi-layered data relationships within a single file. Beyond strings and objects, JSON supports a limited set of other values: numbers, the booleans true and false, and null. The second fundamental structure is the array, which is an ordered list of values. Arrays are defined by square brackets, with each value in the list separated by a comma. These two structures, the dictionary and the vector, are standard across computer science, making the format highly predictable for developers. By using these nested constraints, a server can serialize complex relational data into a flat text format that is efficient for network transmission and easy for a client to process. Once the raw text arrives at the browser, the system must convert it into a structure the computer can actually use in its memory. This involves transitioning from a flat string of characters into a structured data hierarchy that a script can navigate and modify. This transition is efficient because JSON is a proper subset of the JavaScript language itself. Because of this relationship, modern browsers include a native JSON parser object, meaning no third-party libraries are required to read the data. The browser uses the json.parse method to handle this deserialization. The method ingests the text string and populates a JavaScript associative array in memory, mirroring the structure of the original file. Because every JavaScript object is fundamentally an associative array, the data is immediately compatible with the browser's execution environment. Developers can then access specific data points using standard dot notation, such as calling glossary.title to retrieve the associated string. The same process occurs in reverse when the browser needs to send updated data back to a server. For this, the engine uses the json.stringify method. This takes the structured object from memory and serializes it back into a flat string, making it ready for transmission over the network. This native capability to parse and stringify data eliminates translation bottlenecks of older formats, making information exchange between client and server highly efficient. Beyond the core JavaScript engine, this parsed data is utilized across various browser interfaces to create interactive content. These are known as web APIs, the interfaces that allow a script to interact with the browser and the user's hardware. Many critical web APIs rely on JSON. Ajax handles asynchronous server requests using JSON. The DOM API uses it to update on-screen content. Web storage saves stringified JSON locally for user preferences, while the BOM and Geolocation APIs also consume the structured data. This creates a complete pipeline. Data originates on a server, is stringified for transport, sent via Ajax, parsed by the browser, and utilized by the DOM API to update the user interface. This consistent cycle of state transfer allows web applications to react and update in real time based on new data or user interactions. JSON's utility comes from its restrictive structure. By limiting data to 2 basic types that are native to most programming environments, it provides the consistent interface necessary for the modern internet to function.